Yeah, hi, I'm Anthony Pascali. I'm the area sales manager for KETIV's Ansys division. Before joining KETIV, I was a CAD manager for over 15 years of working with Autodesk products.
I'm John Dow. You could call me JD. I used to work over at Disney where we use Ansys Mechanical to modify a lot of ride vehicles and attractions.
So a lot of people ask us why we partnered with Ansys, and it's very simple. Our main focus always has been and always will be to empower today's innovators and manufacturers by offering the best technology and supporting and helping them evaluate those solutions. We evaluated every software simulation package available, and Ansys won. They offer the most accurate, the most powerful, and the most respected simulation package on the planet for engineers, PhDs, and designers.
So for today, we're going to be going over Discovery Live, but we just wanted to show you a preview of the Ansys products that we offer. So over here, you can see that Ansys can simulate different types of multi-physics. You have structures, optics, fluids, electronics, semiconductors, and in the red box, you could just see that's the only part of the software packages that we'll be going over today. But there's a lot more to Ansys, and if you're interested, please contact us after the webinar.
And we're willing to offer those demos 7 a.m. to 7 p.m., 7 days a week, right?
I don't think so. I don't think that was in our contract when we negotiated.
All right. Well, pretty much all the time, Monday through Friday.
Okay. So we're going to be turning it over to Wally for the webinar.
Okay, thank you for giving me the opportunity here to showcase Ansys's newest product family, which is the Discovery product family. And I am an application engineer, and so I just wanted to kind of walk you through, give you an introduction of what the tool is all about, and hopefully, if there's interest, show you where you can get some learning information and to learn more about the tool and how you could eventually acquire it as well. So interface is pretty easy. I'm going to go ahead and just show you that one of the cool things I like about Discovery is the fact that we can open up a lot of different file formats. It's CAD agnostic. So there's file formats from all different major CAD tools that we can open, generic file formats, even faceted file formats. It's just a file open, which is really nice. So if you have a tool already where you could create your own geometry or where the geometry is already created, great. If not, you can also use Discovery's space claim engine to do the design. And that's what I wanted to show you today. So what I have here is just a simple little compressor. It's sitting on a little bracket there. And I'm a design engineer, and one of the things I notice is that there's a lot of vibration with this motor, and it's causing a lot of stress in this area. And one of the things I wanted to do was see if I could come up with some sort of mount design that would help support it and reduce some of that stress, and also let it vibrate to a certain extent, without damaging the other structural components. So let me just jump right into it. I'm going to go ahead and just start designing something. I mean, the cool thing about Discovery is that you don't necessarily have to have a completed design here. Like, what if you just wanted to compare a couple different ideas that you had and narrow them down to maybe one or two, and then move on to some detailed design, or whatever. You just wanted to maybe have something. Hello, testing. Testing. Hello. Yeah, you just wanted to mock something up, have something designed, maybe just to communicate it with somebody on your team. Hey, what do you guys think about a design that looks something like this, for example? So here, what I've done is just started with a very, very simple design here, and my goal is to have the software guide me through what additional improvements I can make to maximize the performance of this bracket. So I've pretty much done a simple sketch, turn this into 3D. At the below, it has an icon there that says Create Solution. So it's really easy to even go from design to simulation here, just in the same interface. So I can come in here and choose between, for example, thermal, fluids, structural, modal. And then as soon as I pick one of those, there's all different types of materials I can choose, or I can add my own. And then I could select entire assemblies. I can select only individual sub-assemblies or individual parts. It's up to me. It depends on what I want to simulate. So here, what I'm going to just do is choose the bracket. I'm going to apply some boundary conditions, like underneath this bracket is where maybe it might be mounted or glued or fixed somehow. So I'm just going to say that it's fixed. When I click on a face, there's a lot of different options, a lot of different boundary conditions that I can set: forces, pressures, moments, displacements, things like that. So I'm going to say fix support here. And then on this face here, maybe what I'm going to do is apply a force or maybe even a moment. So I think maybe a moment might be one of the things I want to look at first. Again, you can look at multiple things, and you can have multiple solutions in this same environment. So I'm going to say maybe a -10 Newton meter moment. That way it's rotating about in the other direction there. As soon as I give it enough information, in this case, a fixture and a force, it immediately starts displaying the results on the simulation. So if you're a designer and you've always wanted to kind of be able to simulate but have heard it's very difficult, this is a great tool because this actually makes it very simple for you to do some quick simulations and help validate your designs. If you're a simulation expert and maybe you also want the ability to kind of experiment with a couple different ideas before you move forward, and you're traditionally used to having like a mesher and it takes a long time to get results, and so experimenting with a bunch of different ideas is not practical, this is a great tool for you too, because this allows you to kind of have all of those very quickly. I can already see where my stresses are just visually on the model. If I look to the right, there's a legend. It's actually showing me the color profile, and as well, it's also displaying that I'm looking at the von Mises stress profile here. Let me introduce you to a little bit of the interface here, and then we'll kind of start really transforming this bracket. Over here to the left is my solution tree. This is what's going to list my boundary conditions and such. So structural 1, my material is aluminum. I can always change that from here. I've got fixed support, got moment defined there. Down below here, I've got the ability to pause play. I can also change the results. So right now we're looking at von Mises. If I want to look at deformation, I can easily just toggle between those. Normal stresses, shear stresses, for example, very easy to kind of toggle and just take a quick look at those and leave those on while you're making edits. I'll leave it on the von Mises for now. And then, one last thing I want to show you is that we can animate the deformation. Sometimes that helps to kind of see an exaggeration of the deformation, and so you can get a better idea of how this tool might deform. So enough with that. Let me go ahead and just start thinking of different ideas. So, and actually, before I do that, I figured what would really help me is, besides just looking at colors and the legend, is to actually have some graphs. So I can turn on some graphs, like for example, I want to look at max stress, max deformation, total volume. So as I'm editing the model, I want to instantly see, did that impact help or make it worse? Was it efficient or inefficient? The change that I made, did it add more weight to the actual part? Is it going to be based on the material that I'm going to use? Is it going to cost too much to make? Do I need to now do some light weighting and things like that? So I'm just going to display these graphs here. And as I start editing the model, we'll take a look and see what displays there. So I'll start with our first easy to use tool, for example, and maybe some of the ideas might be something simple like, all right, can I just add some, fillets in here? Will that, reduce the deformation or stress to an allowable amount, for example? And so here I went ahead and added fillets, and we'll go ahead and see that display here in just a moment. So if you look at my graphs here, it instantly updated that. So you have design point 1, which is before the fillets, design point 2, which is after. And so you can kind of see there, we've got that display. If I want to, change ideas, maybe what I want to do is try doing a chamfer instead of a fillet. How does that affect the overall part there and the performance? So, chamfer looks like it, has a little bit higher in stress than the fillet, and I suspect that's because of the sharp corners, but it's also managing the deformation well, and obviously I'm increasing the volume. So, this is the kind of stuff that I may be interested in early on, without investing too much time in, some heavy validation simulation, which is going to take hours just to report back whether some things like this are going to be beneficial or not. Let me go ahead and remove these and then just go in a different direction. Maybe what I want to do is take a look at whether adding ribs would help here. So I'll use the same tool that I use to turn this sketch into a surface and turn it into 3D. I'm using it to copy edges. It's called the pull tool. So really easy to use. If you have another primary CAD tool that you use and you have the feeling that if you want to use a different tool, it's going to take a long time to learn, and because of learning where all the buttons are and where all these things are located here, with one tool called pull, I can do a lot of different things, helping minimize that learning curve. So I've got the ribs selected. Actually, I'll probably leave it right there in the center, and again, just kind of animate deformation and kind of learn a little bit more about how that rib is impacting the performance of this. So the rib looks to be like it's supporting that center part. I see a little bit of deformation on the sides, but if you look at the graphs, it's really telling here, right? Deformation is really improving, but it's still not handling the stress well. So maybe what I need to do is just think about adding more of these ribs. If it's kind of helping out in one area, maybe I could kind of add more to this. So let me go ahead and move this one to the left. That's the cool thing too, is I started with it in the center, but I want to move it. I can just use a simple tool called move to move it. If you think about also traditionally today, you probably have to go back into some sort of a sketch environment, edit that initial sketch, reposition where it's located, have the model update. It takes a lot, there's a lot more steps involved, whereas here it's something that looks to be like a lot of steps are compacted. So here I went ahead and patterned the ribs using, again, the move tool. Very easy to do. I've got a count of 3. And again, I'm taking a look at, while everything's turned on, the simulation's running, the deformation is animating, and I'm, starting to see that maybe this rib design is really going to be something that I want to focus on. So simply adding fillets or chamfers isn't going to be enough. And maybe a combination of both. Maybe after I put these ribs in, I'll come back and add some fillets and chamfers, fillets or chamfers to the inside to help out. So that's just a quick setup there. But what if what if I'm thinking, what do I do? 2 ribs, 3 ribs, 4? Which is going to be better? How thick do these ribs have to be? So the cool thing about this also is I can incorporate parameterization. So I can have the tool help and guide me quickly, kind of bounce through all of those scenarios and help me make that decision a lot quicker. So let me go ahead and just see if I could parameterize here the thickness of this rib. Let's go ahead and place it on the backside here. Let's go ahead and parameterize that. Okay, cool. So now over here back in the solution tree, I've got the ability to add a parameter study. Okay, so let's see how that's done. We're going to go ahead and bring up those driving dimensions that I created. Like, for example, the count right now, I didn't really customize the name, so I just left it at the default name, group 2. But we'll start with 3 ribs. Maybe we'll go to 5 ribs, and we want it to be done in, let's say, I don't know, 4 steps or so. So we'll go ahead and add that. And then we'll also maybe look at the thickness of the rib. Maybe we want to go from like a 1.5 to maybe a 3, and we want to do that in maybe 4 steps. So I'll go ahead and add those scenarios. What if I want to do all permutations? So what if I want to mix and match some of these things? I can also do that. And you can see I'm going to quickly run through 16 design points here, in a fairly rapid amount of time. And it's going to display all these values for me and help me quickly see that. So let's go ahead and start that. And I love that it's also, going to update the model in real time right in front of me. It's just really impactful as a design engineer, somebody who's maybe not a simulation expert, but just wants to improve their design, ahead of time prior to sending it downstream to either a simulation expert or, to do that final validation and testing in a more mesh-based simulation tool. So here you can see as these things are kind of going along, the values are being populated. geometry is being updated, and we'll just kind of sit here and just give it a second or two to finish, and then we'll be able to pick either by looking at this chart, or I'll be able to show you a graph, and it'll do like a Pareto Front where you can just kind of take a look at the kind of somewhere in the in the center, kind of something that is the best of both worlds. So, or in this case, all three worlds, right? That minimizes stress deformation and keeps the volume pretty manageable. Now take a look at my graphs too. Notice how there's new colors being introduced. So as these different groups are being calculated, it's also superseding these graphs. So I can look at these trends and not have to toggle back and forth between them. I can just look at them kind of all at the same time. So again, let me talk a little bit about the technology here real quick while we are still waiting on the next 5 design points. This is running completely off my GPU. So I don't have a mesh set up here. I didn't have to spend time kind of delling that in. I'm literally leveraging how much GPU horsepower I have. So based on how much available RAM, it's going to basically discretize this model, break it up into, for example, voxels, and kind of treat it that way. Now, if I wanted to maximize the usage of my GPU above the pause button, there is the ability to move this slider. So I can have higher fidelity, more accurate results, but it's also going to use more of my GPU horsepower. So it's definitely advantageous to have a beefy GPU. That way you can get the most accurate and most precise calculations in here, and then take that and move that forward through the simulation workflow. I want to point out that it works specifically with NVIDIA GPUs right now. So if you have any other type of GPU, unfortunately we don't support those today, but that may change in the future. So for now it's NVIDIA GPU only, and I have a Quadro, so it's going to have to be a pretty powerful one, and we've got hardware requirements too that we can share with you to make sure that you've got the right hardware. So my parameter study is done. I'm going to be able to then just click on this little chart button here, and you can see I've got a Pareto Front that could be displayed here depending on what I want to see. So for example, if I want to look at if deformation and volume are important, maybe I want to look at both of those and kind of find one where it's got the least amount of volume available with the most acceptable deformation. So I don't know, I'm thinking somewhere right in this area here. So design point 10 or design point 3. I'll go ahead and just click on design point 3. And what you're going to see is the model is going to update to that design point, and it's going to have that one there for me. And for example, let's say that's the one that I want to choose. That's the one that I want to move forward with. It's just a file save as, or I could port this over to our next simulation tool just by clicking up here in the Workbench tab, so I can send it on and do a more sophisticated simulation. I can also export these results out in a table too if I want to document and keep these saved. So that's very easy for me to do as well. In the interest of time, before I pass it along, I just want to give you another thing to imagine. So far we did this with aluminum. Yeah, we did this with aluminum, and maybe real quick, you wanted to, you're experimenting with rapid prototyping, and your simulation tool, for example, can't handle, faceted data. I want to show you that we can run these same simulations, looking at faceted data like STLs, for example, and still be able to, have it be as easy as this. So I'm going to go ahead and just kind of do something similar here. But my bracket's, going to be based on something that I would 3D print. Let me go ahead. Oh, actually, let me thicken this guy a little bit here. And then let me thicken this guy here to that. I'm going to use our lofting tool just to kind of have it create something for me that, is just organic, something like that. Very simple. But I want to go ahead and start a new simulation. Now, if you think about this also, you're probably closing this off, opening up another, another project, starting up again, importing the model, where here I can just say add a new solution. And this time I want to do maybe again structural, and I can choose any other type of study that I want, but I'll do structural, and this time maybe it's plastic. Maybe it's going to be some sort of an ABS plastic, that's going to be printed by my 3D printer, and I want to basically take a look at that. So right away, I have a new structure, a structural simulation in my tree, and I can just start applying those boundary conditions again the same way. Actually, before I even do that, let me go ahead and do something even more fascinating, and that's to add lattice structuring in here. So it's going to be 3D printed. I want to be able to lightweight it. So I want to be able to have some internal honeycomb or lattice structure get created. So that's all available within here, within this design engine here. So let me go ahead and make sure those are set for 1 millimeter thickness. And I want something like maybe a 40% fill density, for example, on this particular model. I'll go ahead and just choose some faces to remove so you can see the inside, so you can see how cool these lattice structures could look. But before I even run the simulation, I want to really see if it's going to work. Or before I go and produce the one to the left, I just want to see if, hey, could we achieve similar performance with the model on the right, being that it's going to be 3D printed, for example. So I'll just set the same boundary conditions, fixed support on that guy there. Up here, we've got a moment being applied. Maybe I'm going to use that edge as a reference. Then I'm going to enter in that moment value. And you're going to see here the simulation instantly start running on this. And this could have thousands and thousands of facets, right? It's an STL. But we're still able to simulate on it and see where we may have some stresses, and also animate the deformation to help us understand its behavior, and set up graphs and things like that. So we're not just limited to BREP models, or where you can also do these faceted mesh-based STL models, and we can simulate those and easily just toggle back and forth again if we're trying to tell a story or whatnot. So so that's all I wanted to show you there. Let me go ahead and show you where you can find some learning information. So here I've discoveryforum.ansys.com is our community forum, where you're going to be able to basically come to see tutorials, application examples, how-tos, hardware requirements, as well as other articles, knowledge-based things. So there's a lot of great areas here that will allow you to really take advantage of Discovery, learn from your peers, communicate with development team and support teams and stuff like that. I did mention that we run on those very sophisticated NVIDIA Quadro GPUs. Let me see where that might be located here. Off the top of my head, I forgot. Here, let's see. Installation resources, hardware requirements. There we go. And you'll be able to see here NVIDIA Quadro with K-class, M-class, or P-class architectures. At least 4 gigs or better. 8 gigs is preferred. There's also this compatibility utility. So if you don't know yet if, maybe you've got a Quadro, but you don't know if your drivers are up to date, or maybe you've got a different type of NVIDIA GPU that's got a lot of RAM, but you want to see if it's compatible, feel free to try to run this. And then if you don't have hardware, but you just want to evaluate it up front first before making that investment, there's also this online cloud-based trial. So you can run a version of Discovery through the cloud, on one of our servers. You can upload your geometry, you can run your simulations, you can see if the tool is going to benefit you before you go out and purchase any hardware to support that. And I think my time's up here, so I'm going to pass it over to the KETIV guys, and I'll close actually with a couple more things. I apologize here that I'm looking at this, and I forgot to mention that there is a learning hub or training center. If you go to ansys.com, there is the ability to subscribe to like a learning hub where you can get kind of classroom-based content on all of our disciplines here. If you want to learn more, make sure you ask your KETIV sales rep, and they'll be able to kind of point you to that information. And then I think there may even be some images that I wanted to show you here. This is kind of an example of what you'll see, kind of the course material there. You see how it's broken up for live, and you can just start the course there. Oops. And then, here's kind of that at the end, which is really nice, is that it does give you a quiz. I love that it does quiz me, because that's really helpful at the end, just to kind of make sure I've captured the knowledge. So, all right, let me go ahead and pass it back here to John. There you go. And there's a chat panel. So if you have any questions, feel free to enter in your questions in the chat panel there. We'll do our best to answer those and get you that information.
Hey, thanks, Wally. This is Anthony Pascali. We do have some questions that have come in through the private. One of them is, can you elaborate on the cloud version that you can use for the appropriate hardware? Can you elaborate on that a little bit? Like, is it subscription?
That's actually a great question. I think that you know, traditionally when you say cloud, people think that they don't need to download the software. They can just run it in the cloud and have it be linked to their licensing. I want to clarify that. So the cloud-based version that we have is strictly for evaluation purposes. So it's literally Discovery installed on one of our servers back at our headquarters that we're letting you remote into and use. But we don't have a cloud-based version. It runs completely on your local hardware resources, your local GPU, and that is a requirement there in order to use it moving forward. So just to kind of clarify that, I'm glad you asked that. Thank you. Does that?
Yeah, that answers us. And our next question is, can you possibly show us a preview of the Learning Hub? Like, is it subscription based? How about the Discovery Forum? Is it possible for you to show us that quickly?
Yeah, actually, I don't know if I have a login to the Learning Hub, but I can certainly show you how to get to the Learning Hub. Let me actually share my screen again. Okay, wait, let's see here. Yeah, share my screen. So when you go to discoveryforum.ansys.com, you may be prompted to enter a username or password. You can also, request one. So once you're in, anyone can get into the forum. So you don't have to own Discovery yet to get into the forum. You can get into it, learn, watch videos, watch tutorials, ask questions. So there's no subscription required here. This is just consider it like just any forum that you want to just go into and participate in. Now, if you go to the Ansys website, though, there is an option up on top that says Customer Portal. You can log into your portal here, and there's a section here for training and support. And in here, you'll be able to go to the Training Center, which you'll be able to log into the Learning Hub if you have subscribed to it. I don't think that my login works for this, but let's just try it here real quick. Yeah, I don't know. I haven't set up a username and password, but it's just as simple as that. Once you're subscribed, you'll have a username and password. You'll be able to access this. And I had just a couple images that you could, that might show it. It's like, for example, when I select Discovery Live, for example, there's these modules that may appear here. I had somebody else help me out with some of these screenshots. And then, once you select a module, then it breaks it down and it has, further workshops. So hopefully this kind of gives you an idea. And again, if we aren't able to answer your question here, or, if you need more information, feel free to definitely contact us, and we would love to follow up with you after to answer those questions. So
great.
Yeah.
Next question is, being able to really import Inventor files and SolidWorks files, can you talk about that a little bit?
Yeah, certainly. I mean, literally, when you go File Open, it brings in the geometry. It brings in like kind of where they're located, for example. What it doesn't bring in is all the sketches and features that are proprietary to Inventor, for example, or SolidWorks, where it was created in. All it brings in is just the CAD geometry. So whether they're large assemblies, sub-assemblies, it doesn't matter. You can mix and match. So I can bring in a SolidWorks assembly and import Inventor models into it and mate them together using Discovery, do mechanisms and things like that. So I can mix and match all I want. We don't bring in the drawing, so it's just the parts and assemblies. And the cool thing is we bring it in like in light speed compared to opening up a traditional assembly in those tools, because we're not having to kind of reread and rebuild every single sketch and feature. We're just bringing in the ready-to-go model, and it just opens up so much faster. You don't have to sit there and wait for it. So hopefully that answers your question there.
Yeah, it does.
And that comes included too, by the way. It's included with Discovery. So you'll have it there. You'll be able to easily import those different file formats.
Okay, well done. The next question is, some of our audience members today have missed the first 3 webinars we've done. They want to know where you can get those. I can either send those to you. If you want to send me your email, I'll bring my email up in a second, and I'd be happy to send you those recordings. Or you can also go to KETIV's social media sites, either LinkedIn or our YouTube channel. So just go to YouTube, put in KETIV, and you'll see the past 3 webinars there that are recorded. Any other questions coming up?
So Wally, there's another question about transferring the Discovery Live studies. Are they compatible with other Ansys products?
Absolutely. And if you can see my screen here, inside of Discovery, I have a Workbench tab. And if I go in there, I can port it to 2 separate places. One, I can port it to AIM, which is our Discovery mesh-based simulation tool. Really nice also if you're a design engineer, because it's got kind of a guided wizard feel. It walks you through the steps. You don't have to know all the different buttons and drop downs and all the different nuances. It kind of summarizes it, makes it very, very easy for somebody who's not a CAD expert to do high-level simulation. And the engine inside of AIM are the same flagship high-level solvers, like in Mechanical and in Fluent and things like that. So you're just using a much easier interface. So you can easily port that. The geometry and all the boundary conditions will carry over from Live into AIM. As well as from there, you can pass it on to Workbench, or you can go from Live to Workbench here. You can click this button. That'll take, again, the model and all the boundary conditions and any kind of parameters that I've created. It will then pass it along to Workbench, where then you could tie in and do more sophisticated simulation with other Ansys products. So we've definitely tried to make sure that you could walk this through the entire workflow, and we're trying to minimize you having to kind of start over again each time. So we want to make this as fluid as possible. So we encourage you, if you want to try that, and let us know how well it works for you.
Excellent.
Yep.
Okay, let me look for the next question. We're getting some good ones here. Can you show the other products, JD?
Sure.
We want to show this, that whatever you've seen today, this Discovery Live is a great tool, and it's primarily for design engineers. But we have probably just showed, as far as the percentage goes, just a small percentage of the tools available. I want to show you a quick shot just to kind of show you. If you look to the far left side of it, where it says 3D design, we showed you a small portion of Discovery Live. Look at the rest of the products that are available. And I think that's important, especially if you're an analyst or an engineer and you want to know, hey, can we do CFD? Can we do mechanical? Can we do computing? Can we do electronics? It's all broken down there. And I want to make sure that everybody, is clear on that.
One additional thing, if you don't mind me mentioning there on that slide, is, traditionally Ansys has been, known for, being the simulation, multi-physics simulation leader. And that with that, you're probably thinking, oh, it's always been an expert simulations tool. But we've seen the benefits of empowering designers early on, right? Giving them the ability to kind of dabble a little bit in simulation. We've seen the impact on that and how much higher quality geometry comes through the door when you're ready to run some of these higher level simulations. So Ansys is doing something new with this Discovery, is they want to open it up to more non-simulation experts, and we have a good reputation of having very powerful and accurate simulation tools. So we hope to just continue empowering all of the users, all KETIV users out there, and just giving you more tool sets to be able to get higher quality and jobs out the door. So thank you for letting me say that real quick. And
yeah,
thank you, Wally.
My pleasure.
Hey, I wanted to bring up next month's webinar. We have a webinar coming up that will be covering the designing electronics enclosure using Ansys Discovery Live. That will be on February 11th at 10 a.m. And Wally had mentioned the free trial of Discovery Live. Please reach out, to either Wally or myself, preferably myself, if you're interested in the free trial. I'd be happy to get that information over to you.
Okay.
Yeah,
that's it.
Thank you, everybody, for
very much.
coming.
Thank you. Take care, everyone.
Okay.